Today I'm going to go over transformations of linear functions. So we'll be able to identify effects of transformations on the parent functions, and also be able to explain how those effects change the parent function using the content vocabulary, such as vertex, translated, vertical, and horizontal. So you're going to need a piece of paper and a pencil for this. So pause the video if you need to grab those two things. So this, I posted a reference sheet for you on Google Classroom for this. So if you want to open that up and have it out as we're doing this, that would be perfect. So, or you can write it down. If you're writing it down, I would suggest making this feel like a whole page and putting in the center of that page what I'm highlighting in yellow. So f of x equals a times b times x plus or minus h plus or minus k. So this slide is just showing you the different transformations on the parent function. So we're studying linear. So this is the different types of transformations that can occur on the linear parent function. So I'm just going to go through and explain what each of these transformations means. So the first one is the a value. So the a is a number outside of parentheses. It would be in front of a set of parentheses. The a would be, if it's negative, a reflection over the x-axis. If the absolute value of a is bigger than 1, then you have a horizontal stretch by a factor of a. If the absolute value of a is in between 0 and 1, then it's a vertical compression by a factor of a. So this is how the a affects the graph. So this is a vertical stretch or compression. The b, so inside the parentheses is the b. So if you see something with, so you see a set of parentheses and then inside you'd see something next to an x. Inside, it would, if b is negative, would correspond to a reflection over the x-axis. If the absolute value of b is bigger than 1, so if the absolute value of b is bigger than 1, then it's a horizontal compression by a factor of 1 over b. And if the absolute value of b is in between 0 and 1, in other words, if b is in between 0 and 1, and it's positive, then the horizontal stretch is by a factor of 1 over b. So notice inside is going to affect your graph horizontally. So b is going to affect it by either stretching it or compressing it. And then the a on the outside is going to be a vertical stretch or compression. The next letter is the x, but the x is just the variable. So there's nothing to describe there. That's just the variable. H. So if this is when it's important. So h, if h is positive, then you move left h units. So it does opposite. So you think positive moves right, but it doesn't. Positive actually moves your graph left. It does opposite of what's there. So the important distinction is that h is going to be inside parentheses with the x. And if h is negative, then it moves your graph right h units. So again, this would be a horizontal shift, left or right. It always does opposite of what's there. The last value is the k value. So k tells you, does your graph move up or down? And this value does exactly whatever sign is in front of it. So if k is a positive, so if you see a plus sign there, then it moves your graph up. If k is negative, then it moves your graph down. So this is a vertical shift up and down. So k moves you vertically, h moves you horizontally. So let me start off by, I'm going to change this display real quick. I just want to give you the graph of the parent function, so where there is no transformation taking place. The parent function of the linear function family is f of x equals x. Remember, we could write this as y equals x if we wanted to. And then I'm going to just go ahead and graph this so that we know what this function looks like. So here's my coordinate plane. So I'm going to make an x and a y. And then I'm going to plot a few points. So I'm going to just show my table here for you. So -1, 0, and 1. So if x is -1, then that means y equals -1. If x equals 0, then that means y equals 0. And if x equals 1, then that means y equals 1. So these are the points that I'm going to use to graph my parent function. So -1, -1, 0, 0, and 1, 1. So this is what your parent function looks like. So pause the video if you need to copy that down. The next piece we're going to do, and we're going to do this for all the examples that we see, is we're going to look at domain and range and end behavior. So we talked about domain and range when we looked at graphing on that first a couple weeks ago. So on that first day. So the domain is -infinity to infinity because I can put any value in for x. There's no restriction along the domain. And then same thing for the range. I could get out any value and then the same thing sort of goes for the range. I could get out any value along the y-axis. So it's -infinity to infinity. So it's all real numbers. The new part that I suspect many of you have not seen before is this end behavior piece. So this is new. So as x approaches -infinity, so that means if I was to go along the x-axis and I was to go all the way to the left, this would be -infinity. They're asking, what's happening to my y? In other words, what's happening to that graph that I drew? Well, that graph, I'm just going to look. -infinity is to the left, so of 0. So I'm just going to look. This left arrow on my graph goes down. So that means my y is going to go down. So it's -infinity. So that's how we get as x approaches -infinity, y also approaches -infinity. So for this one, you're just looking at the left arrow for the first one. For the second one, as x approaches +infinity, so here you're looking at what happens as x goes to the right now. So as x's get bigger or approach +infinity, our y's, to figure out what's happening to our y's, we're just going to look at our right arrow. So if we look at this arrow up here, it's going up. So it's going towards +infinity on the y. So for the second piece, as x approaches infinity, y approaches infinity. And so we'll do this analysis for every function that we graph today. So pause the video if you need to finish this up. So let's look at some transformations. So the first one, example 1, describe the transformation and then I want you to graph it. So f of x equals x plus 1. So the plus 1, remember, we're looking at whether that plus 1 is inside a set of parentheses or outside. So there are no parentheses here. We just have x plus 1. So that would be considered to be outside. So outside is, remember, is always a k value. So this is a k. So the function is translated vertically. Remember, k does exactly what the sign says. So k is going to move this 1 unit up. And so when we graph it, I'm going to use a table again. So x, y. And for my x's, this time I'm going to use -1, 0, and 1. Same ones that I used before. Then I'm just going to plug them into the function. So if I plug that in, remember I could rewrite this as y equals x plus 1. And then I would do -1 plus 1 is 0. 0 plus 1 is 1. and 1 plus 1 is 2. So I'm just going to plot each of those on a coordinate plane. So here's my coordinate plane, x and y. And then I'm just going to plot each of these. So negative 1, 0 is going to be this point right here. 0, 1 is this point right here. And 1, 2 would be this point right here. So this is my function f of x equals x plus 1. So pause the video if you need to copy this down. So let's look at domain and range. So notice I could put any value in along the x-axis. There's no restriction on the x-axis. So the domain will be negative infinity to infinity. The range, in a similar manner, just like when we studied it that first day, is all real numbers. There's no restrictions on what I could get out on the y-axis. So it'll be negative infinity to infinity. That new piece, the end behavior. So let's look. As x approaches negative infinity, what does y approach? So I'm going to look. I'm just going to start at this point here. And I'm going to go to the left. So this would be my negative infinity. So as x approaches negative infinity, what's happening to the left arrow? So this left arrow, notice, is going down. So this would be negative infinity along the y. And then as x approaches positive infinity, so if I go to the right along my x, so to positive infinity, what's happening to my right arrow? So here's my right arrow. My right arrow is facing up. So this would be positive infinity. So as x approaches positive infinity, y also approaches positive infinity. So pause the video if you need to finish this one up. So example 2. Describe the transformation and then graph the function. So f of x equals x minus 5. So again, you're going to want to look. That minus 5, is that inside parentheses or outside? So notice the minus 5 is inside parentheses, so that's going to correspond to an h value. So the function is translated horizontally 5 units. And remember, h always does opposite of what's there. So since it says minus 5, I'm actually going to move my graph 5 units right, not left, because h does opposite. So to graph this one, we will want to graph the parent function, and then we're going to want to move it right 5. So when you're graphing and you have just the horizontal translation, you will want to use the parent function and then just move it left or right. So remember, those ordered pairs from the parent function were -1, -1, 0, 0, and 1, 1. So this was the parent function that I'm drawing in black. The new function I'm going to do in blue. So I'm going to move it 5 units to the right. So I'm going to take each of these points and move it 5 units right. So this first point at 1, 1 is going to move to the point. So I'm going to move it 5 units right. So 1, 2, 3, 4, 5. So this is going to move to 6, 1. So that's where that one's moving. The next point is going to move to the right to 4, 0. And this point is going to move to the right to 3, -1. So these are your new points for your graph. So I just took each of those points on my parent function and I moved them right 5. So pause the video if you need to copy that down. For the analysis part, domain and range. So remember, domain and range, so we're looking at the blue function, because that's our new function. That's our f of x equals x minus 5. The domain, there's no restrictions on x, so it's negative infinity to infinity. The range, again, there's no restrictions on the y. I can get out any y value, so it's negative infinity to infinity. And then the last piece, end behavior. So as x approaches negative infinity. So looking at this blue piece, I'm going to erase the parent function just so we don't get confused. So if we're looking at that blue function there, if I go to the left along the x-axis, so if I approach negative infinity, what's happening to the left arrow? It's going down, so that's approaching negative infinity. And then if I start here and I move my graph to the right, so this would be plus infinity along the x-axis, notice that right arrow is going up. So that's positive infinity on the y. So this says x approaches infinity, y also approaches in positive infinity. So go ahead and finish this one up if you need to. Pause the video, go ahead and do that. So describe the transformation and then graph the function. So we have f of x equals negative 2x. So if you look at your handout, the negative 2 is out front of the x, so it's not inside parentheses, so this would correspond with an a value. So the function is reflected because there's a negative in front of the 2, so I know that's a reflection because the negative. So it's reflected over the x-axis since it's an a value, and it has a vertical stretch by a factor of 2. So we're going to graph this. So here's my coordinate plane. X, Y. And then to graph it, I'm just going to pick a couple of points to plug in. So let's say we choose -1, 0, and 1. So if I plug in -1, I get -2 times -1, which is +2. If I plug in 0 for x, I get -2 times 0, which is 0. And if I plug in 1 for x, I get -2 times 1, which is -2. So I'm just going to plot each of these ordered pairs on my graph. So -1, 2, 0, 0, and 1, -2. And then I'm just going to connect those 3 dots. So here is my function. So pause the video if you need to finish copying this. The next piece, again, we're going to want to analyze the domain, range, and end behavior. So for f of x equals -2x, just like all the examples we've done so far, the domain is -infinity to infinity. And the range is also -infinity to infinity. So there's no restriction on either the domain or the range because we have both of the end arrows. The next part, the end behavior. So as x approaches -infinity, so remember that means as x goes to the left here, so here's -infinity on the x. What's happening to my function? So what's happening to this blue graph? Well, we're just going to look at the left arrow. That left arrow is pointing up. So since it's pointing up, that means that I'm going towards positive infinity. So as x approaches -infinity, y approaches positive infinity. And then for the second part, as x approaches infinity, so for this one, if I go to the right on the x, so that's x is going towards positive infinity, what's happening to my graph? So what's happening to that blue line? Well, notice that right arrow is pointing down. So that corresponds with -infinity. So in this graph, as x approaches infinity, y is approaching -infinity because that the right arrow is pointing down on that blue graph.